This week on the show, we tell you how to learn OpenBSD makes computers suck a little less, how Unix works as well in more detail, with FreeBSD 12.1 looking at benchmarks that are running very well on the Ryzen Threadripper 3970X. We tell you about the BSDCan call for papers, of course, and what's required there, and a HardenedBSD Infrastructure Goals update for you as well in this week's episode, the first one of this year in BSD Now. BSD Now, episode 331, Why Computers Suck. This was recorded on the 18th of December 2019, and I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
And welcome to the first episode of the new year 2020, fresh out of the box. So recorded in the last year, but published in the new year. So we basically skipped over the date line here perfectly well. And bringing you, first of all, best wishes to the new year. Success, luck, health, most of all. And of course, thanks for listening to us this last year, and hopefully you will stick with us in 2020 as well. And of course, we have headlines as always for you. The very first headlines for the new year are why computers suck and how learning from OpenBSD can make them marginally less horrible. This is over at telegraph.ph, and they have an article here that the following document is an attempt to consolidate down a number of threads spanning separate discussions from around the net that they have been having on the subject of operating system development models and OpenBSD. And they will break that into several sections, each of which will handle separate pillars of their thinking. And so far, they've formed some semi-articulate thoughts that they can share.
So they say, to begin, it makes sense to focus on Microsoft's Windows operating system. In Redmond, a large number of engineers are focused on trying to make the Windows operating system effectively for the needs of the market for private business and government agencies. These organizations typically have large workforces who never want application-breaking changes introduced into the operating system. Frequently, it is the case that corporations running Windows for their workforce have paid outside firms sizable sums of money to develop custom software that is mission-critical to the company's core business. Companies who make such investments often view that money they paid for the development of this software in a similar manner to how they would view an investment in any other asset, which is to say that they have the expectation that it will continue to function for years. Worse yet, in these outside firms often don't exist 10 years after the initial development of the software, and those firms don't offer source code to their customers, so their customers end up stuck with this old static artifact, a build of the software that can't be updated for a new operating system. So you hire a company to build custom software for your closed source operating system, and you use it, but the problem is 10 years later, that company might not exist anymore. You don't have the source code, so that doesn't help you. And if the new version of Windows is not backwards compatible, then you end up with this useless bit of software instead of a working application. And they said, even in cases where customers do have access to source code, their scope of work and have no incentive to write code that will be easy to use. Have you ever tried to look at the source code for 20-year-old software? Sometimes it doesn't really give you the warm fuzzies.
Yeah.
Anyway, without the ability to modernize an application's code base, introducing any API deprecations into an operating system can be catastrophic for enterprise customers who find themselves in this situation. As a result of these problems, Microsoft has made a conscious decision to avoid altering its operating system's functionality in a manner that would introduce a change to the application binary interface. Hence, Windows can be conceptualized as a fundamentally enterprise-oriented system with an enterprise-oriented development model. Changes are carefully introduced to the system, which often must be layered on top of existing functionality so as not to disrupt or otherwise alter the existing functionality of those APIs.
The legacy code.
Yeah. Backwards compatibility is certainly desirable given many programs compile to machine code and it's not realistic to update them to match a moving spec. However, this comes at a significant cost. Architectural improvements are much more difficult to introduce when you can't change the API. and deprecated old code segments to fix bugs, improve performance, or introduce binary incompatible features become impossible. And so that's kind of their starting point. And then they say that the enterprise development model is the cancer that killed the modern operating system. So to introduce this section, they'll share an anecdote from one of their friends. Prior to the release of Windows 98, Microsoft reflected on their previous major releases with specific attention paid to the unwillingness of some customers to upgrade from, say, MS-DOS to Windows 95. It turns out a large subset of the users who were able to upgrade but were otherwise unwilling to had opted to maintain an MS-DOS system because many of the programs which had run in MS-DOS were somehow incompatible with Windows 95. As a result of these observations and this trend, then Microsoft viewed the strategy of selectively porting highly popular content to Windows 95 as key to increasing the rate of adoption of the new version. This way of thinking, which would ensure sales of new versions of Windows would not be lost to existing copies of the ABI-incompatible userland software, became ingrained in both the minds of engineers working at Microsoft and people who wrote software for it. The priority of backwards compatibility became so important that prior to the release of Windows 98, Microsoft traveled from their offices to local retailers so they could purchase whatever off-the-shelf software was available at the time and then make sure that would work on the new version. The purpose was to implement separate, often entirely unique mitigations per program to manipulate these programs to run on the new ABI. For example, SimCity apparently made use of a flag in a particular region of memory, which was available in MS-DOS, but on Windows 98, the same address and flag signaled the operating system that it was time to shut down.
Ooh. Oops.
So then they talk a little bit about how Linux dealt with that, and then talking about how much better could things actually be if we abandoned that enterprise development model. So now we're going to compare that enterprise development model with non-enterprise development, something like, say, OpenBSD, which does not hesitate to introduce ABI breaking changes between versions. One of the most commonly referred to pillars of the project's philosophy has long been its emphasis on clean functional code. Any code which makes it into OpenBSD is subject to ongoing aggressive audits for deprecation or otherwise unmaintained code in order to reduce the cruft and the attack surface. Additionally, the project creator, Theodorat, and his team of core developers engage in ongoing development of proactive mitigations for various attack classes, many of which are directly adapted by various multi-platform user applications as well as operating systems themselves. Frequently, it is the case that introducing a new feature, not just deprecating old ones, introduces some new incompatibility between previously functional binaries and OpenBSD. To prevent the sort of kernel memory bloat that has plagued so many other operating systems, the project enforces a hard ceiling on the number of lines of code that can ever go into ring 0 at a given time. Current estimates guess the number of bugs per line of code in the Linux kernel to be around 1 bug for every 10,000 lines of code. Thinking this is in the context of scope creep, looking at the Linux kernel, which could be as much as 100,000 lines of code versus the Windows NT kernel, which underlies Windows 7, 10, and so on, is 500 million lines of code. You quickly begin to understand how much more functionality goes into those privileged components than maybe you would hope for.
Sure.
And so this way, OpenBSD, with its model of only having to support the ABI for a year, means that they're welcome to just change it when they develop something new, and by not having to be constantly slowed down by the baggage of keeping the old stuff working, it makes it much easier to go forward. One of the main ways that OpenBSD can do that is because most of the software you're going to run on top of OpenBSD, you have the source code for, and when you compile it, it can adapt to the changes in the API. Whereas if you only have binaries, then they have to have been built specifically for that ABI that you're going to use, and that would result in a separate version of some commercial application for every different version of OpenBSD, and that probably wouldn't make sense. And FreeBSD is kind of somewhere in the middle with an ABI that attempts to maintain stable across any major version. So FreeBSD 12.0 and 12.1, the ABI is supposed to be the same, so a binary compiled for one will work on the other. But when it's time for 13, we can break any ABIs we need to in order to not have to haul around that backwards compatibility forever.
clean up some old craft.
There is also the cross-compatibility there where we can, it's a supported thing on FreeBSD 13 to run a 12 binary. It's just not everything will be there necessarily, and you might have to install an extra package that provides the backwards compatibility for certain versions of libraries or whatever. Anyway, to say, as nice as backwards compatibility is for a user convenience perspective, this feature comes as a result of a static kernel application binary interface. This trade-off is essentially indistinguishable from an increasing time preference, or in other words, declining concern about the future in comparison with the present. This can be seen as a continuous layering of hacky fixes bolted on features and, maladapted APIs. And unremovable remnants of abandoned code segments left in place purely to ensure that applications continue to run. These issues not only cause their own problems, but in aggregate cause a huge creep in the number of lines of code, which just slows down future development because you have to deal with the interactions with all that code.
Mm. Isn't also ZFS also deprecating some functionality now?
Yes, let's look at deprecating ditto blocks and the send receive dedupe feature, which is different than dedupe itself.
Yeah, so it's not just limited to operating systems, so also subsystems have to deal with that.
Yeah. Anyway, there's lots more to read there. So if the snippets I give you were interesting to you, you would probably appreciate the whole article.
Mm-hmm. Then next up, we have an even longer article about how Unix works. Become a better software engineer. And that is also very long, so we skip most of the smaller parts, but it's definitely well worth a read. So it starts with Unix is beautiful. So the author here allows us to show a little YouTube video to print some happy little trees for us. But it's not going to explain a bunch of commands that are there. That's boring, and there's a million tutorials on the web doing that already. They're going to leave us with the ability to reason about the system. So every fancy thing you want done is one Google search away. But understanding why the solution does what you want is not the same. That's what gives you real power, the power to not be afraid. They'll put just enough commands here for us to play along, assuming we're starting from scratch, and they explore concepts like the practice in a shell, and then, oh yes, I get this, of course, and then you can continue on. And along the way, they'll also figure out what a shell really is. But we can't begin without getting into the minds of the creators, exploring Unix's philosophy, and that's what they start with. So they provide a little abstract here. They have a philosophy section, then they go into files and file systems, then the processes, then layers in Unix, and how the shell works, as well as at the more towards the bottom, package managers, brief history of Unix, and a conclusion with footnotes. So in the philosophy section, that's probably what we covered many times already. The philosophy behind Unix is write programs that do that one thing and do it well, write programs to work together, and write programs to handle text streams, because that's the universal interface. So Unix also embraces the worse is better philosophy. This thinking is powerful. On a higher level, we see it in a lot of functional programming. Build atomic functions that focus on one thing, no extra output, and then compose them together to do complicated things. All functions in the composition are pure, no global variables to keep track of. Perhaps as a direct result, the design of Unix focus on two major components, processes and files. That's what we're going into next. And for example, in the processes section, they write that the browser you're running is a process. So is the terminal, and if you have it open. If not, now is a good time to open it. So they keep it in a kind of a tutorial section or way.
Yeah, an interesting one to look at is the files permissions section. It has a bit of a graphic showing what those different fields when you do ls actually break down to. Whether it's basically a flag. The first one is what type of file it is, whether it's a regular file or a directory or a character device or whatever. And then you have the read, write, execute permission for the owner, and then the group and the other. And those can also be changed sometimes, like if you have the set group or set user bit and a bunch of other different things like that. But that's a fairly basic thing in Unix, but being able to look at it graphically like that can be quite interesting.
And then they go a little bit in the file linking, like ever wondered why moving a gigabyte from one directory to another is blazingly fast, while copying the same might take ages. and they show how that works. Hard links versus symbolic links, and they have a little ls output providing the inode numbers, so you can see how they change or not change if you provide a different link type. And so that illustrates this concept.
Well, yeah, and for the copy versus move thing, if you're moving from one directory to another and it's in the same file system, you're really just renaming the file, so it doesn't take long. But if they happen to be different file systems, or say different ZFS datasets, then you actually do copy and then delete. So the move program has basically an optimization that says, oh, if I can just rename the files to make it work, I'll do that and it'll be fast. Otherwise, move is just copy and then delete the original once the copy succeeds.
Then they talk a bit about the file structure, how everything is organized in Unix, in the hierarchy, below / etc, user, mnt, and other directories below those.
Right, and how access control works, and how set user and set group ID kind of stuff works, attributes on a file and a process, the life cycle of a process.
With nice illustrations.
Redirection, so how you can send the output of a command into a file, or just the errors into a file, or send the errors over here and the results over there, and that kind of stuff.
So this is a very nice introduction to Unix and the concepts for complete newbies. Maybe I'll link to that in my Unix lecture notes. Then they talk about layers in Unix, the kernel versus the Unix utilities. So we usually say this is kernel and the other thing is user land. So to distinguish the two. And the kernel exposes these APIs for anything built on top of that to work with the kernel from a user land perspective and vice versa.
But they even get into some of the more interesting things for the shell, like the path environment variable and how the searching works, and why some commands can I just type the name, but other commands I have to specify the path of where that command is, and how does that work?
Yes, yeah, that's a good concept to know about. Then they talk about pipes, of course, which is important to know, and also provide a nice illustration how these different standard in, standard out redirections work, and how you can manipulate those in case you need to.
Brief history of Unix, and a little talk about how Linux is kind of like Unix, but not exactly, and so on. Or even, how OS X fits into that picture. And then in conclusion, we say Unix is a full-fledged operating system, and Linux is a kernel, the core of an operating system inspired by Unix. They focus on doing one thing and doing it well. Everything is either a process or a file. The kernel is the core, which exposes system calls, which your utilities can then leverage to perform work. Processes work with files as input and output, and we have control over those files, and we can redirect the outputs to different places, and it wouldn't make a difference to the process. The pipe can redirect output from one process to another process. So one program's output becomes the other process's input, and the program doesn't care which program's reading that input. And every command from the shell first forks, then execs, and returns an error code at the end.
It's happening in the background. You don't usually see it very often, but it's happening all the time. Yeah, read their whole article. It's definitely worth a visit. Even if you just look at the pictures, they kind of nicely illustrate how these things work. I think we should go into the news roundup this week. This very first week in our recording of 2020, we found an article on Phoronix. FreeBSD 12.1 runs refreshingly well with AMD Ryzen Threadripper 3970X.
So they're firing up FreeBSD 12.1 on the new Ryzen CPU, and in particular, comparing it to a bunch of different Linux versions. I think they tried to compare it to Dragonfly, but ran into an issue. In particular, they noted how FreeBSD 12.1 works out of the box, whereas Linux still needs some manual workarounds on this newer model of CPU. Might just happen to have been timing when FreeBSD 12.1 was released quite recently, but a little bit later than, say, the latest Ubuntu or whatever. So first, they took at some benchmarks. So looking at the Go build benchmark, you can see FreeBSD basically right in the middle with everybody else because it's pretty OS agnostic. We wouldn't expect to see much difference, but we see that FreeBSD 12 builds Go a little bit faster than CentOS 8, and maybe a tiny bit slower than Intel Clear Linux. But can see FreeBSD ahead of CentOS and Ubuntu in that particular case.
Yeah, and the last one is Windows.
The garbage collection, you see some odd results where FreeBSD is much slower, but I'm guessing that's something Go specific going on there.
Probably, yeah.
Looking at the Java benchmarks, again, basically FreeBSD beating out Ubuntu and being about right in the sweet spot with all the other Linuxes for running that Java benchmark, although Windows is apparently doing slightly better at Java there. But looking at the Java runtime for Python, again, FreeBSD beating out Fedora and Ubuntu, and Windows being slightly behind there. But yeah, in general, you're seeing FreeBSD performing basically as good as Linux on the newer hardware. Interesting, for a couple of the tests, they compared stock FreeBSD with its Clang-based compiler with FreeBSD using GCC 9.2 to compile the application. And they, like for ImageMagick, they see slightly better speeds with the newer version of GCC, possibly taking advantage of platform-specific stuff in the new Ryzen CPUs.
Probably.
Because basically, using the newer GCC moves FreeBSD from about the middle of the pack on rotating an image to way out in front if you use the newer GCC. And then for the zoom and enhance feature, vanilla FreeBSD is already in the lead, but the GCC version also provides the best two results, actually.
Yeah, it depends on what you are using every day. Are you zooming in a lot of pictures, or are you doing other stuff?
Looking at H.264 video encoding, FreeBSD out in front with the GCC 9.2 giving it a small advantage. Windows is apparently just a little bit faster still, but FreeBSD beating all of the Linuxes for encoding video.
Oh, okay.
For the 7-zip compression test, it looks like they only have the GCC result, not the Clang result, and it's significantly worse. I'm guessing there's an explanation behind that somewhere.
That should be investigated a bit.
Looking at Stockfish again, FreeBSD basically tied with CentOS out in the lead. XZ compression, FreeBSD is about in the middle of the pack there. Windows is the worst. Converting a WAV file to a FLAC, vanilla FreeBSD seems to be the slowest, but FreeBSD with GCC is way out in front, outside of Intel Clear Linux, which seems to have something else going on, giving it another boost there.
Mm.
But in general, as you can see, FreeBSD is usually towards the front of the pack rather than the back in most all of these benchmarks.
Yeah, well competitive in the field.
Interesting result.
You can read through the full thing and look at the graphs they provide for each of the benchmarks. But if you're in the market for an AMD Threadripper, then I guess that's not a bad purchase. Okay, and then we finally got the BSDCan call for papers listing. So everyone was excited, of course, to get this out and hopefully submit something early so that they can look at submissions, not just on the last day like many other conferences get. But Dan Gill, the ceremony master of BSDCan, writes in his message, BSDCan 2020 will be held on the 5th to the 6th of June 2020 in Ottawa, as always, in the university there. And will be preceded by 2 days of tutorials on the 3rd and 4th of June. This is Wednesday and Thursday. And the note says that the change of months in 2020 backs to June. So be careful not switching that around and arriving a month too late or too early.
BSDCan had previously been in May quite a few times. Then we had it in June, and that seemed to work better. But some people complain, and due to venue availability and so on, we were back to May for a little bit, but we're back to June, and I think that works better. Maybe not always for some people because of the academic calendar in their country, but looking at turnout numbers, June has usually gotten a bigger turnout. So, And yes, Dan reminds people that the conference actually starts on the evening of the Tuesday, so that'll be June 2nd. So when you're planning your trip, you probably want to try to arrive early enough on Tuesday that you can join us for the pre-conference dinner and goat bath.
Ah, yes, that's a good get-together before the main conference starts and chatting with people over drinks.
And if things are starting early in the morning on Wednesday, you want to be there by Tuesday night anyway, right?
Yeah, arrive early to be in the right time zone and well rested. So back to the call for papers. They're looking for talks that should be designed with a very strong technical content bias, as always, because BSDCan now has a standard for high quality content in the talks, and it's shining.
Yes, and if you kind of have question whether your idea is very applicable, you can always look at the last dozen years of BSDCan and see, is there things kind of in that level of focus. But it doesn't have to be complicated technical stuff. It just has to be technical. I just mean business development or marketing type presentations are not what we're looking for. It doesn't have to be like super developer assembly stuff.
Yeah, within the kernel or something.
A very large portion of the people attending BSDCan that are sysadmins. So anything, it doesn't have to be developer-y. It just has to be, technical and interesting.
So that caters to a couple of people, and there's usually a track that appeals to someone. And they also have a good hallway track. So the schedule for the call for paper is December 1st. So this is started a bit late. Sorry. But yeah, it couldn't be helped, apparently. So January 19, 2020, it's where the proposal acceptance ends. So maybe you have some time over the holidays to think about an idea and write a proposal and submit that early so that they can get that looked over.
Michael W. Lucas has a great blog post, because he's one of the people on the program committee for BSDCan, about what you can do to make your submission stand out, in particular, making sure you provide answers to all the questions that the program committee is going to have to ask to decide if they should pick your talk over some other talk.
Yes.
But you basically want to explain who you are, what you want to talk about, and how it's interesting to other people that would be attending BSDCan.
Exactly. And as much information you provide, the more likely it is that you get selected. There's always competition, of course, because they only have so many talk slots. But if you just provide a one-sentence abstract, then,
Yeah, if you can string together a couple of sentences and form, one or two paragraphs, that'll work well. Again, if you look at the archive of BSDCan, for each talk, you'll see what the person wrote as their synopsis, and you'll get the idea that it should take about this much room on your screen and be formed in sentences that people will read. Because basically, that synopsis you send is, you'll be able to edit it, but it is what will become the description of the talk in the calendar that people will use to decide whether they want to come to your talk.
Yeah, and see that. Yeah.
On the schedule, there will be 3 or 4 talks against you. So you need to write something compelling enough to make me decide to go to your talk instead of one of these other great talks that's happening at the same time.
And so they will send out, at least from the schedule here, on 19th February, a month later, because they need to look up through the flood of submissions, of course, and select the proper ones. The confirmation will then be sent out, and then they will contact you with details about travel and other stuff. Make sure that you don't miss BSDCan, and yeah, we look forward to seeing you there.
Hopefully everybody can attend BSDCan, and that many people will submit talks so that we can have the best of those selected as our program. Because again, when BSDCan is going to try to have a mix of talks so that there's interesting stuff for all the different type of BSD people that will show up. There are people that only work on, say, ports. They don't really write code. They just keep applications working and administer systems. And so we need talks that aren't just, this is how the newest compiler stuff works for debugging. It's like, there's a good chunk of people that's very interesting too, and there's a chunk where it isn't. And that's why BSDCan can manage to have 3 or 4 or 5 talks at once, because there's enough different areas of interest that we can keep everybody happy.
Or if you're using BSD in your company in an interesting way that's not very common, that's also probably a nice talk that people are interested in going to.
Yes, I think that was one of the highlight talks at EuroBSDCon, the videos on YouTube, but about using FreeBSD in payment processing. And, it was mostly about the absurdities of what the payment card industry auditors are looking for and the mental gymnastics to check the right boxes on an audit form and so on. But just hearing about people's experiences is very interesting. I think one of the very first BSDCan talks that I saw that really resonated with me was about managing the internet infrastructure in the high Arctic in Canada. It's like, so there's this heated shipping container in the middle of town, and it's got 3 FreeBSD computers in it and a satellite uplink, and it has to keep working. And there are times of the year where there are no remote hands available because everybody from the village is out hunting or whatever during that season. But the internet has to keep working, even though we can't even get somebody to toggle the power on a machine or something. And it's like replacement parts. Yeah, there's one time in the spring when we can fly out and send stuff, or we can only fly out certain parts of the year because the rest of the time the runway isn't frozen, and so the plane can't land. Or whatever.
Yeah, that's a very interesting use case. And if you have similar use cases like that, or just scale the BSD in like the millions, for example, I don't know. Give a talk about that. That's certainly interesting because the developers that are there are always interesting to see, like, where is my code being used? No matter whether it's FreeBSD, OpenBSD, or NetBSD, or what other BSD you're using. It's certainly an interesting collection of talks every year. All right, then we have a story from the HardenedBSD camp about the infrastructure goals they have. And it's kind of a summary from 2019, but definitely good to look back now. Sean Webb writes here that 2019 has been an extremely productive year with regards to HardenedBSD's infrastructure. Several opportunities aligned themselves in such a way as to open a door for near-complete rebuild with a vast expansion. The last few months especially have seen a major expansion of our infrastructure. We obtained a number of to-be-retired Dell R410s. The crash of our nightly build server provided the opportunity to deploy these R410 servers, doubling our build capacity. His available time to spend on HardenedBSD has decreased compared to this time last year. As part of the rebuilding their infrastructure, he wanted to enable the community to be able to contribute and was structuring the work such that help is just a pull request away. Those in the HardenedBSD community who want to contribute to the infrastructure can open a simple pull request, and he'll review the code and deploy it after a successful review. Users and/or contributors don't need access to their servers in order to improve them. So their primary goal, or his particular primary goal for the rest of 2019 and into 2020, this is ongoing, is to become fully self-hosting with the sole exception of email. He wants to transition the Source of Truth Git repo to their own infrastructure, and they will provide a read-only mirror in GitHub. And as he develops this infrastructure, he's going with human rights in mind. HardenedBSD is in a very unique position, he writes. In 2020, he plans to provide production Tor Onion services for the various bits of their infrastructure. HardenedBSD will provide access to its various internal services to its developers and contributors. The entire development lifecycle, going from development through production, will be able to happen over Tor. And transparency is also a key moving forward, that the logs for the autosync script are now published directly to GitHub. The build logs will be soon too, and logs for all automated processes and the code for those processes will be tracked publicly via Git. Oh, that's an interesting thing. This will be especially crucial for development over Tor. And it seems integrating Tor into the infrastructure so deeply increases the risk and maintenance burden. However, they believe that through added transparency, they will be able to mitigate that risk, and periodic audits will need to be performed and published. Okay, that's what we can read in the future then. We have future content. So he hopes to migrate HardenedBSD site away from Drupal to a static site generator, and they don't really need to be the dynamic or to have these capabilities that Drupal provides. The many security issues Drupal and PHP both bring also leave much to be desired. And he closes with, so that's about it. He spent the last few months of 2019 laying the foundation for a successful 2020 and is excited to see how the project grows. Yeah, and we'll be interested to see how this went along and follow the progress and report it to you. All right, time to the Beastie Bits this year, the first ones this year. I keep repeating. The first item that we found here is FreeBSD, which is a KDE Plasma flavor now available, or has this flavor now available.
Yeah, so instead of only having an XFCE build, you can now get FreeBSD with KDE Plasma.
Yep, and if you haven't looked at FreeBSD, it's FreeBSD, not FurryBSD. I keep mispronouncing that. FreeBSD. Look at their website. They have a nice showcase of what the desktop looks like. It's a desktop distribution, and they provide a little handbook as well as a blog and some community content.
Yep. They also have a link from their presentation they gave about FreeBSD at the Knoxville BSD user group. So if you want to watch a quick video to get an idea of what's actually going on there, that might give you, some insight.
Yeah, and we're looking forward to maybe people trying this out or have tried this out maybe over the holidays and wrote a little blog post or a longer one maybe. And if you send that to us, it will appear in a future episode. Then we found the Dragonfly BSD. There's a Git thing or a thing on Git. With Verge.io to fix the LUN scan issue with Google Cloud. I think we reported on that.
Yeah, this is a fix for the Verge.io SCSI driver. Yeah, I think we did talk about it last week.
Okay, whoops, sorry. It's good to repeat it for the people who might have missed that.
But then we have an especially good one here from the LPI, the Linux Professional Institute, which now runs the BSD certification exam. And they've broken down their objectives for creating the BSD specialist concept. And so they're looking at the list of different things that you will need to be able to prove you can do to be certified as a FreeBSD specialist. This includes installing BSD and managing software on it. So that's, operating system installation, package management, system startup configuration. So modifying how the system configures itself as it reboots, configuring hardware, and also setting BSD kernel parameters and the system security level and so on. So sysctls and things like that. So being able to basically install FreeBSD, configure it, and install some software on it. Then we have storage devices and BSD file systems. So that's understanding disk partitioning and disk labeling, creating file systems and maintaining their integrity. So FSCK if it's UFS and Scrub if it's ZFS and stuff like that. Controlling mounting and unmounting of file systems, managing file permissions and ownership, creating and changing hardened symbolic links, finding files and the basic hierarchy of the files on BSD so that you don't have to resort to a search every time you're looking for a file because you should be able to know where it is supposed to be.
Oh, yeah.
Then basic BSD sysadmin stuff. So managing users and groups, automating system administration tasks by scheduling jobs, cron tab, and things like that. Maintaining the system time, so NTP, things like that. Logging, mail transfer, printing, user sessions, etc. Network administration, so understanding the fundamentals of IP and basic network configuration, network troubleshooting, configuring client-side DNS and DHCP and all that kind of stuff. And then your Unix skills, so that's using the shell and working with the command line, performing basic file management, create, monitor, and kill a process, use simple regular expressions, perform basic file editing, and writing and customizing shell scripts. But they're looking to expand on this as well. So if you have input on what should go into being certified as a BSD specialist, they'd like to see more added to that. Because yes, maybe under the file system stuff, we could add maybe a little bit of ZFS specific stuff, but not too much.
Mm-hmm. Yeah, so get in touch with the LPI, and they're always looking for people to write instructions or so-called little lessons.
Right, because yes, the other thing is that as part of this, there needs to be teaching material that people would go through to learn this stuff to be able to pass the exam.
So you're writing this for future exam takers, I would say. And language needs to be in English, and they can also pay you on a little thank you note. So this is not complete for free. So if you're interested in that, get in touch with the LPI and mention that you want to write for the BSD certification exam.
It's BSD agnostic. So like when you look at each of these chapters, you can see there's commands and files that are common between all the BSDs, and then specifically what you need for FreeBSD, NetBSD, and OpenBSD. So if you want to make sure that your favorite BSD is properly understood, you want to make sure that all of the commands in those categories for that OS are listed there. Like I notice off the top of my head, on the partitioning chapter, they're talking about fdisk and disk label. They don't have a G part for FreeBSD, and that definitely should be on there. And so somebody is going to need to edit the wiki and add that.
Because we want to represent the latest releases and what the features are in there.
Well, and G part's been the way to do it for the whole time I've been a FreeBSD developer.
Yeah, for a while now.
I was a user back in the other part, but
yeah, so that's why we need more people from the BSD community to write the proper instructions so that other people can be certified properly. Okay, then we found something, a ZFS sync async zil slog explained article.
Yes, so this is from JRS, Jim Salter, who I think still co-hosts the TechSnap podcast in my place. And yeah, so based on a conversation on the ZFS subreddit, he does a good job here of explaining the difference between a zil and a slog. So a lot of people think that a zil or ZFS intent log is when you have that special SSD for speeding up certain types of workloads. But your pool always has a zil. Always. A slog is what that SSD is called, a separate log, meaning that instead of the normal zil procedure, which is just write it as part of the pool, we're putting it on a special device that's faster. So you always have a zil, and the dedicated SSD is called a slog, not a zil.
Yeah, that's important to know.
And so he says, it's frequently misunderstood part of the ZFS workflow, and I had to go back and correct some of my own misconceptions about this during the thread. So IX Systems has a reasonably good explainer up on their website with the great advantage that it's error checked by Matt Ahrens, and which is one of the founding ZFS developers. But it can also use a diagram or two to make this a little more clear. So Jim has a diagram. So if you look at it here, you have a bunch of work happening. As you can see, they're represented by this weird stack on the side. And some of the work is asynchronous, meaning the application just says, please write this data down, and then the application continues and goes about its work. But some writes are what are called synchronous writes. And these are things like in a database, where a database is going to say, all right, somebody just ran a database query, and so I need to write this data, but I'm going to wait, and I'm not going to tell the user that that database query is done until the file system tells me that data is definitely on disk and will survive a power failure. But this can also happen for other cases, like if you're going to rename some files, a bunch of other reasons why you would want to wait and make sure that this completes. But in general, what happens with an asynchronous write, so if you're just copying a file, is that ZFS is going to actually aggregate all the changes you're making to the file system in memory. So if you're running FreeBSD and look at top, you'll see there's, on the arc line, there's a section called anonymous, and you'll see it starting to fill up as you write more data. Either because that amount of data got too big, and we don't want to use up all of our memory, or it's been long enough, the default is 5 seconds, then we will take all that data that's been aggregated and write it out to disk as one big chunk. Because writing one long linear chunk on especially spinning hard drives is a lot faster than doing something else. So yes, writes come in, they start to accumulate, and then once we have a good chunk of them, we just splat it down to disk. This allows the application to go as fast as it wants, and everything works great. And ZFS has this subsystem called the write throttle, where as you're expanding that balloon of the aggregation, and it's when that gets too big, it's taking a chunk of it and writing it to disk. But if your application is writing so fast that your disk can't possibly keep up, ZFS will start, as that balloon gets too close to full, it will start inserting slowdowns so that eventually the application will get to the point where it's writing exactly as fast as you can write out to disk. And that will keep the disk as busy as possible for the whole time, giving you the best performance. Anyway, the problem with that system in ZFS is that if you have a synchronous write come in, and you have to say, all right, this write has to be safe before we can continue, you don't want to stop and write all 150 gigabytes or 150 megabytes of data that's outstanding to the disk just to be able to say, oh, that one 16 kilobyte chunk for the database is safe now. So what happens is when a synchronous write comes in, we kind of split it into, we fork it and have two copies. So one goes into that aggregation in RAM, and at the next transaction group, it'll go out to disk like normal. But in order, the problem with that is if the system crashes or the power goes out, all the stuff that's aggregated in RAM is gone, and it never actually made it to disk. This is fine if you're just copying a file because, does it really matter if you were 30% done or 50% done? Not really. But with a synchronous write like a database, it really does matter. So in addition to put the copy in memory that'll go to disk eventually, we also put it in a record in the ZFS intent log. And so only once that's there, and we've made sure that's safe on disk and will survive a power failure, whether it's part of the regular pool on your regular disks or is on a separate device, the slog. But basically, we make sure it's there, and once it's safe on a disk, then we can tell the consumer, all right, that write is finished. It'll be safe. In a normal case, the copy of that's aggregated in memory gets written out, and it works just like it was an asynchronous write. And everything's fine, and the ZIL entry gets marked as not useful anymore, and everything's fine. If the system does crash, then the copy of the synchronous write that was in memory is lost, and all the asynchronous writes are lost as well, or the ones that hadn't been flushed yet, so up to 5 seconds worth. When the system reboots, it sees in the ZIL, oh, there's a write I promised I would finish, and it didn't actually finish. So it will read it out of the ZIL and finish that write. And that way, the promise you made the program or the database was kept. Right? And so there's a second diagram you can see. When you reboot, it take it from the ZIL, put it back into the aggregation of memory, and flush out the transaction, and all of those promises you made are kept. The problem with that is, if you're using, say, spinning hard drives, that synchronous write could take quite a few milliseconds to finish. Because, your hard drive is busy doing other stuff, and it's going to have to move the head to the spot in the ZIL, and then write down the change, and then so on. Whereas when you have a separate log device, you can have a very fast device like an SSD or an NVMe or even NVDIMM now that have really, really low latency. And that way your synchronous writes are going to this device that's going to keep its content through a power failure or a crash. Again, if the system doesn't crash, that was a wasted effort, right? You just used up a bunch of flash for no reason because it'll actually get aggregated in memory, written out normally, and then that slog entry can be thrown away. But by writing it to that faster device, you can return to the database faster, which means the database can do more work in less time. And then, if the system does crash, you can read those entries off that separate log device, aggregate them in memory, and write them out normally. And then it talks about a couple other more fine-tuning stuff you might do.
And there's also a couple good articles in the blog itself, in the BSD category, or other categories.
Yep, and the ZFS category. So yeah, the big thing there is if your main workload is just asynchronous, right? If you're just copying files to and from it and so on, then having that separate log device isn't going to help you much. And because, like I said, the entry on the slog or in the ZIL basically gets invalidated once that transaction group finishes. Even worst case, you're probably only looking at needing to store 30 seconds worth of data on that SSD. So getting a really big SSD for that might not actually be useful. Now, because all of these database writes are going to be going to this disk, it can wear out very easily. And so larger drives have longer lifetime. They can take more writes before they wear out. So sometimes there are advantages to using a bigger drive, but most of those times, if you want to get that advantage, you need to not use the whole drive. You need to under-provision it, so leaving lots of leftover flash completely unused so that the drive firmware can swap it in or whatever. But in general, you don't want a big slog because you're never going to write that much data. And if you're just using it to, say, store media files, then you don't need one at all.
Yeah, just passing through.
Because yes, outside of when the system crashes, you're literally just writing data to the SSD and then throwing it away 5 seconds later and never reading it. Of course, it is providing the guarantee that if the system crashes, you'll be able to still have your data. But
yeah, but good to distinguish that, and reading that article will hopefully provide all the necessary insights. Then we have a BSD licensed combinatorics library from Devin Teskey. So this has been posted on FreeBSD Announce. This is a announcement for a new utility library for FreeBSD that's available for review. So she provided a link to the review on the Fabricator. And she writes that combinatorics is the study of combinations. For example, calculating how many possible combinations given a set of items and some parameters, such as how many or a range of how many items to select. Iterating over every possible combination to perform some action for each, with support for position indicators so that you can prematurely terminate. You can pick up at the last combination where you left off. And find combinations of numerical items that produce a particular sum, quotient, product, or difference.
Yeah, I think the first time I really looked at, one of the interesting places where combinatorics comes in is actually in ZFS RAID reconstruction. If you have, you say a RAID Z2 of, 10 disks or something, when ZFS gets a checksum error, it doesn't necessarily know. It doesn't know which disk is wrong, right? So you have 10 disks and you read data from 8 of them and you got the wrong checksum. So it does this combinatorics thing and say, try basically every different combination of 8 out of the 10 disks until I find one that has the correct checksum. And then from that, I will know which disk might be wrong.
Yeah, that's a use case for that. And so she continues with, while these problems have been solved or partially solved in language such as Perl, Python, R, Haskell, and others, her implementation is faster than all of them, she writes, and BSD licensed, as well as written in C with bindings for Perl and Python with R and others forthcoming, and works on macOS 10, Linux, Solaris, BSDs, etc. with minimal dependencies. If you're interested in this kind of work, look at the review. Maybe you find something that she missed, or provide some feedback if you can make use of this in interesting ways. And so that's good feedback to have. The next story in our list of new things, BSD-like, is the SSL client versus server certificates and Bacula FD. That's a post from Dan Langell.
Yeah, anyways, it says, sometimes I forget about TLS/SSL X509 certificates being available in both client and server versions, particularly when it comes to private certificate authorities. When you're running your own thing or say using Let's Encrypt, that's usually a server certificate. So a server can prove to the client, hey, I'm actually the real FreeBSD.org, not some imposter and so on. And Dan says he uses security/SSL admin port for that. But today in particular, I spent about 2 hours trying to debug issues with adding TLS to existing Bacula clients. And I was getting this weird error when it says incorrect authorization key for file daemon with client or at client rejected. Problem was solved by creating a client certificate for the file director or file daemon to connect to the director. So just like we can use server certificates for a website, say your bank, to prove that it's the real bank, you can actually use client SSL certificates for a client to prove, hey, I'm actually a trusted client. I have a certificate from our certificate authority saying I am actually a trusted client. And so you can use this with Bacula to say, I will issue a certificate for each of our machines, and only with that certificate will you actually be able to make a connection to our backup server.
Mm-hmm. Yeah, so that's how he solved it. And Dan also provides all the commands usually that he runs to see that this is not forgotten and other people can pick it up.
Yeah, in particular, he was creating a server certificate when he actually wanted a client certificate. And so he wanted to use the option to create a certificate signing request and then go and sign that with his certificate authority that he's using for Bacula rather than creating a new server certificate.
So that's the breadcrumb for next time that he encounters this problem or someone else. And so they know what's going on and how to solve that. And then in our list, we found that Max Desktop is planning to come to FreeBSD. This is a Facebook post for a change. So they write, good morning, folks. Here's a little update from the Max Interactive Desktop. So the Max Xmas edition is in the works. Okay, yeah. Max goes FreeBSD maybe before the end of 2019. Okay, so we'll get updates to that. Actively looking for C, C++/Java developers. So if you're in the market for a new job, then maybe you're interested in this. And there's a Max Slack channel invite link. So that provides probably more information and get you more details about what this is about.
Yeah, but another interesting graphical desktop that supports FreeBSD, or wants to anyway.
Mm-hmm. Yeah, so these are efforts that we want to support. And definitely, if you have some free time and you're looking for a job, maybe that's something that you're interested in. Okay, fresh new year, fresh new questions and feedback. But in the last couple of weeks, our supply of questions has run dry a little bit.
Yeah, we recorded a lot of episodes all at once.
Yeah, so that's the reason why. But if you have something interesting found on the web, or an idea, show topic, or a problem that you're trying to solve with BSD and you're kind of stuck somewhere, then send all of this to us, or a single one of those, to feedback@bsdnow.tv. And there's a big chance that you will end up in the feedback and questions, and we'll answer your question, or as best we can. The first who did this week is Tom with the ZFS mirror with different speeds question. Tom writes, "Great show, guys. Thank you. Is it a problem to create a bootable FreeBSD ZFS mirror with one faster disk and one slower disk? Will the slower disk slow down the faster disk, or will the performance be as fast as the fast disk and the slow disk will just catch up when it can?"
So yes, there's some interesting details here. And I will admit that my previous laptop, my T530, specifically was a mirror of half of the hard drive and half of the SSD. There's no problem in creating a ZFS mirror of a fast disk and a slow disk, especially for the operating system. The answer to your second question is a little more complicated. So will the slower disk slow down the fast disk? Yes and no, only sometimes, kind of, maybe.
Depends.
And will the performance be as fast as the fast disk and the slow disk will catch up eventually? No, the ZFS will always keep the mirrors in sync. However, remember we were just talking about the aggregation that happens in memory when you do a write. When you have two different speed disks, when you're reading from the disk, ZFS will take the read and break it down into chunks and give one to each disk. Now, the fast disk is going to finish first, but it gives one chunk to each disk. And when the faster disk finishes, it'll get another chunk and maybe another chunk. But then the slower disk is done, and so it'll take a chunk. And basically, ZFS will keep both disks busy doing the reads until all the reads are done. And it will take advantage of the fact that some of the disks might be faster than the other disk. It was mostly to make sure that even if all your disks are the same speed, if one is acting a bit slow, it doesn't slow everything down as much. So on reads, you will get basically the performance of the two combined. So it'll be very nice. So rather than the performance of the fastest disk, you'll get the sum of all the disks for read performance, which is good. For write performance, if you're doing this asynchronous write, you're not going to get the performance of the fastest disk. You're going to get the performance of your RAM, which is even faster.
Mm-hmm.
So when you do asynchronous writes, they just go into memory, and then ZFS will write them out. Now, when ZFS is actually flushing that, it's going to write to both disks.
Because of a mirror.
And, the slower one's going to be slower. And so it'll take longer for that transaction to close. But same thing goes for the synchronous writes. And so, yes, the synchronous writes might be a bit slower. You're not going to get the performance of the fastest disk because it has to wait for all the disks in the mirror to finish. This can also happen if you have a three-way mirror. If you have three different disks combined into a mirror, again, you're waiting for all of them. It's not just a quorum. You wait for every disk to be finished. So no, ZFS will not let one disk get ahead because then if there was a checksum error on part of the data that only exists on one of the disks, there's no other place to get it from, and ZFS has now broken one of its promises. So it doesn't do that.
Mm-hmm.
Now, ZFS can catch up when a disk gets behind, but that's for different reasons. So if a disk got disconnected temporarily, when you reconnect it, it won't have to resilver everything. It'll be, oh, that disk has up to transaction 150. We're on 160 now. Let me just sync out the changes for those 10. But you can't like use that on purpose to have that SSD or the hard drive be trailing behind the SSD. It doesn't work like that.
That's not practical.
But in general, it works fine. And, especially if it's your, the system you're running an OS on, like a laptop or something, you're probably not going to notice because the reads are still going to be fast and most of the writes are buffered through memory and are not going to be stuck waiting. So if you're copying large files around or something, eventually maybe that's slower. But remember, if you're just writing large amounts of data, spinning hard drives aren't that slow. Right? Even if you're updating a whole bunch of different files, which normally would be slow on a hard drive, in ZFS, all those writes get aggregated in one big blob and written out as if they were one big file. And so because ZFS is doing the log structure type thing, you're not suffering the same penalty on writes on a spinning hard drive that you would normally anyway with like UFS. And so it should still work fine.
Aren't there some changes coming down the ZFS, OpenZFS pipeline that will show us which disk is slow and which is a little less slow? Like I/O statistics?
Like the zpool IO stat is going to have latency stuff in it, if that's what you mean, yeah.
Yeah, that's what I'm getting at.
Yeah, like you can get that today with gstat on FreeBSD, and it's like that applies outside of ZFS. But yes, the ZFS IO stat in the new OpenZFS port does provide more information about latency and so on.
Yeah, because I guess people bought maybe the same disks for the pool initially, and then maybe one disk is dying slowly, then more slowly than the others, and you don't notice that one disk is smaller in your big pool
or slower rather than smaller. But yes, it can be a good failure indicator when one of your disks, one of a large number of identical disks, is taking a lot longer to do the same amount of work.
Yeah, and so having a kind of a measurement instrument to see which disk might be the one that is the slow snail in the pool. Okay, good to know this. And next is Jeff with Knowledge is Power. Ooh, that sounds intriguing. Jeff writes, "Hi Benedict and Alan, I've been catching up on recent episodes. Excellent. And in episode 319, Alan mentioned in an aside that Michael Lucas's Jails book was not selling well. Alan rattled off a number of possibilities for Jails, and then Jeff thought, hey, I have some use cases for those, so why not pick up a few BSD books and expand his knowledge as he slowly begins a process of adopting FreeBSD as his primary open source operating system at home. Then he's currently working his way through Michael and Alan's collaboration on ZFS, FreeBSD Mastery ZFS, and almost immediately understood, or thought it was mentioned in a different episode, why Michael said that as he began the Jails book, he needed to write several other books first, given how interconnected all of the pieces of the operating system are. So he also purchased a copy of Absolute FreeBSD. Michael is very happy, I guess. So thanks for that. 3rd edition and SSH Mastery, with the latter also having quite a lot of applicability to my day job as a Linux cluster administrator. Yeah.
Yeah, because like even the ZFS book kind of depends on you having the basic disk management stuff from the storage FreeBSD Mastery files and storage, and there's one of the FreeBSD Mastery books that covers like partitioning and all that, and that was something we kind of just had to assume you already knew going into the ZFS book if we didn't want it to be stretching out into a third book.
Yeah, so, and then Jeff further writes, I had previously purchased some of Michael Lucas' older books, or other works, and I think that with a few more years of professional experience, I now have an even greater appreciation for his brand of sysadmin black humor. The books aren't all jokes, of course, but I find them to be well written with easy to understand examples. I will certainly be purchasing more books from the Mastery series in the near future. There's one coming out very soon, or might be by the time you listen to this episode. One question in closing. Is the compensation to the authors any different between the print version of the book and the ebook, Kindle, for example? If so, that could affect which edition I elect to purchase.
I don't know the answer to that. Although, if you buy the books directly from Michael's website, the Tilted Windmill Press, he gets a slightly larger chunk of the money. But when you buy through Amazon or a bigger bookstore like that and leave good reviews, that pushes his book further up in the search results and so on those platforms. And that can end up selling more copies of the book.
Yeah.
While he might make a few cents less off your copy, if it sells 10 more copies, he'll have made more money in the end. So no matter where you buy it, or whether you buy the Kindle or the physical version, make sure you leave your feedback, reviews for it on the book sites, and that, whatever's easier for you is probably the better answer. But buying it from the larger stores has some advantage to Michael that's slightly indirect compared to what percentage, how many cents he gets for each copy of the book.
It's nice to see that you get a lot of knowledge out of this and advance your sysadmin career and make your entry into the BSD world. If you're stuck along the way, let us know. And I guess Michael will be very happy to hear this. Good feedback. Okay, thanks, Jeff. And next is Johnny, giving a response to episode 324 question from Jacob. Johnny writes here, "Hi guys, can you pass on this response to Jacob about the LS colors on macOS Kitty terminals? Not sure if it works since I don't own a Mac, but this is what I found." So he provided a link about how you can optionize probably the Apple macOS 10 terminal color LS output. But yeah, that's how you disable the colors in Kitty, and or change them if they're not too unpleasant for you, but you still want to get the performance out of it.
Yes, and that's from our friend on Twitter. What's his Twitter handle again? Nixcraft.
That provides the occasional BSD hints and tips for you. And in this case, it matches the episode question from Jacob. Okay, so thanks for that. See, we don't have to do the work all the time. Other people can chime in. We're still looking for other solutions for like the beeping of the ThinkPads when you suspend them.
Yes, I think we found a little bit of information, but not all of it yet.
Okay, we're still digging. Okay, then as a bonus, we have Pat with an announcement about the NiceBug meeting. That's the first one for the new year. So Pat has wrote us a message saying, "Hello, Alan and Benedict. Happy holidays. I hope this message finds you all doing well. Below is the info for our next NiceBug meeting, the first of many in 2020. So January 8th, 2020, there's the meeting happening. Please note new location. Blink, blink. Be careful. Go there to the new location, not the old one. It's in Chartbeat 826 Broadway, 6th floor, New York."
And so the speaker is Amitai Schleier, who was one of the very first interviews we did on BSD Now back 320 weeks ago. And his talk is about what is not Qmail. It's not Qmail, and it's not NetQmail. It's something else.
That's a nice teaser, yeah.
Yeah, so he says, we all use email, so we all use email servers. Not Qmail is software for running an email server. Someday, if we do a good job, some of many articles about how and why to run a mail server will recommend running not Qmail. So not Qmail is a community-driven fork of Qmail, beginning from the NetQmail, where that project left off. Again, trying to provide stable, compatible, small release of which existing Qmail users could easily upgrade to. Not Qmail also aims a bit higher by developing an extensible, easily packaged, and increasingly useful modern mail server.
Oh, that's interesting.
Because I think the core of Qmail itself hasn't changed since I used it in 2002.
Okay. Never change a winning team or running software? Well,
Qmail had this slightly weird license, I think, that said that you couldn't easily modify it.
That might be the reason.
It was written by Daniel J. Bernstein, and it was secure. And if other people edited it, it might not be secure anymore.
Okay.
And that's why you have these forks of it. Because the idea is that if it's Qmail, it's the one that Dan wrote.
Okay, yeah. So look out for NiceBug meetings in the future. We'll announce them as soon as possible, as soon as we hear about them, and the next show is coming up. And so, that's a good way to start your BSD experience in New York. That's pretty much it for this episode. The first of many more in this year, I predict. Thanks for listening. and keep us posted about new things in the BSD world to feedback@bsdnow.tv, and then that will be future content for episodes to come.
Thanks, everybody, and Happy New Year.